Episode 1 proved the complete HTTP path, but restart the application and every work item disappears. Today we will replace only the storage implementation with Entity Framework Core and SQLite. The create and list contracts stay the same. That stability is the point of the first checkpoint. We will add a DB context, explicit mapping, a reviewed migration, asynchronous database calls, and provider-backed integration tests. Along the way, the build will stop on a vulnerable native dependency, and a list query will fail only at runtime because SQLite cannot translate the chosen date type. Those are not distractions. They are the lesson. Entity Framework Core is not simply a magic replacement for SQL. A DB context represents a unit of work and tracks changes to entities. The model describes tables, keys, required values, lengths, and indexes. A provider translates LINQ and model operations into behavior for a particular database. SQLite, SQL Server, and PostgreSQL share EF Core concepts, but they do not have identical types or SQL capabilities. That is why a test using a fake provider cannot prove a query will run against the real one. We will keep SQLite for low setup friction and call out the places where a SQL Server application needs separate verification. The web host reads a named connection string and registers one scoped feature LabDB context. Scoped lifetime aligns one context with one web request. The work item store also becomes scoped because it depends on that context. We do not open connections or create tables in constructors. Configuration selects the provider and location, application code consumes the configured context. For a production SQL Server deployment, this registration changes to use SQL Server and the migrations must be created and tested for that provider. A migration is provider-specific source code, not a universal database script. Explicit mapping makes the intended database contract readable. The work item has a primary key. Its title is required and limited to the same maximum length as the domain rule. The creation time is required, and an index supports our newest first list query. Application validation gives callers useful feedback. Database constraints defend integrity when another code path or a bug reaches persistence. Those are complementary layers, not duplication to remove. Avoid creating an index for every property. Start from actual query shapes, then measure. Here the list endpoint already orders by creation time, so the index has a concrete reason to exist. The repository pins a local .NET EF tool so every learner uses the same version as the runtime packages. Generate the initial work item's migration into source control, then read it. Up should create the work items table and intended indexes. Down should reverse that change. Do not treat generated code as unquestionable. A rename can appear as a destructive drop and add. A required column added to existing rows needs a safe backfill strategy. Migrations are deployment artifacts that deserve review. After review, apply the migration explicitly with database update in development or through the deployment pipeline in production. The EF store keeps the same capability as episode 1 but becomes asynchronous. Adding an entity marks it for insertion, and save changes async commits the unit of work. The list query uses as-no tracking because the endpoint returns read-only response models and will not update those instances. Tracking every row would consume memory without helping this query. The cancellation token flows from ASP.NET Core into the database operation, allowing abandoned requests to stop work when the provider supports it. Do not add async keywords to CPU-only methods, but database I/O is exactly where asynchronous APIs protect server throughput. It is convenient to call database migrate every time the web application starts. That convenience becomes risky when several production instances start together. A migration needs a long schema lock, or the application identity should not have schema modification permission. The teaching app applies ensure created only in its isolated testing environment. Development uses an explicit database update command. A production system should run reviewed migrations through a deployment step or a single controlled migration job, observe the result, and only then release normal traffic. Startup should report whether the expected schema is present, not quietly compete to redesign it. The first restore did not pass. EF Core's SQLite dependency graph selected a native bundle version with a high-severity security advisory. Because the project treats warnings as errors, the build stopped instead of hiding the problem in yellow text. The fix is to pin the current patched SQLite PCL raw bundle, restore again, and verify a clean dependency graph. Do not disable vulnerability auditing simply to make a tutorial build green. Package dependencies are part of the application you ship. This real interruption became a better teaching example than a perfectly scripted restore would have been. The next failure appeared only when the list endpoint executed. Creation succeeded, but ordering by date-time offset produced a provider translation exception and the API returned 500. SQLite does not support that ordering in the same way SQL Server does. The in-memory implementation could never reveal this. For the low-friction SQLite course model, we store an explicitly UTC datetime and keep the UTC suffix visible. A SQL Server production model may choose datetime offset and test it with SQL Server. The general rule is more important than the specific type. Model time deliberately, document the convention, and run important queries against the provider you deploy. The test factory supplies a unique temporary SQLite file and starts the application in a testing environment. The schema is created only for that isolated database. Connection pooling is disabled so disposal can remove the file reliably on Windows. The same create, validation, and list tests from episode 1 now pass through EF Core and the real SQLite translator. These tests are still fast, but they cover far more than F's in-memory test double. For SQL Server-specific behavior, the next level is a disposable SQL Server container in integration tests. Match the test cost to the risk you need to cover. Replacing memory with EF Core changed lifetimes, failure modes, deployment artifacts, dependency risk, query translation, and test strategy. The external work item contract stayed stable because episode 1 established it first. That is the value of vertical checkpoints. In episode 3 we will add ASP.NET Core identity, require authentication for the work item routes, derive ownership from the server authenticated principal, and prove that one user cannot read another user's data. Authentication will be treated as identity, session, authorization, and resource scope, not merely a login form.